US Physics Olympiad, year 2013, USAPHO, Semifinal exam. Problem A2. A solid round object of radius r can roll down an incline that makes an angle theta with the horizontal. Assume that the rotational inertia about an axis through the center of mass is given by formula I equal beta m r square. The coefficient of kinetic and static friction between the object and the incline is mu. The object moves from rest through a vertical distance h. Question A. If the angle of the incline is sufficiently large, then the object will slip and roll. If the angle of the incline is sufficiently small, then the object will roll without slipping. Determine the angle theta c that separates the two types of motion. Question B. Derive expressions for the linear acceleration of the object down the ramp in the case of I rolling without slipping and I2 rolling and slipping. Solution. First, let's draw the picture for this process. This is our free body diagram for this rolling. We have gravity force mg, we have force of friction F, and we have normal force N. Now let's assume that angle is small enough. It means that this motion is rolling without slipping. Let's write equation for this motion. For linear motion along this incline, we have this equation: ma equal mg sine theta minus force of friction. For rotational motion of this object, we have equation I alpha equal fr, where I equal beta mr square and alpha equal acceleration a over r, because this motion is without slipping. So we have these conditions. Now we put this I here and alpha here, and we will get that force of friction equal beta ma. And we can put this force in the first equation and find what is acceleration. So acceleration equal g sine theta over 1 plus beta, and now we can put this in equation for force of friction, and force of friction equal beta over 1 plus beta multiplied by mg sine theta. Now we have to check that this force cannot exceed mu multiplied by normal force. So mu mg cosine theta, that's maximum force of friction we can reach. From here we can find what is a critical angle. Tangent theta critical equal mu multiplied by 1 plus 1 over beta. For angles less than this angle, we have acceleration equal g sine theta over 1 plus beta. But for angles more than this one, we can just use a regular equation for force of friction, because if we have slipping, we have force of friction equal mu mg cosine theta, and after that acceleration equal g multiplied by sine theta minus mu cosine theta. That was the answer for question I2, and the answer for question I1 is acceleration, this one, g sine theta over 1 plus beta. So we just answer for all questions.